As night gradually settles in, and the last sounds of a busy day slowly fade into silence, perhaps you've looked up at a sky filled with stars and quietly wondered, where do we truly exist within this vast universe? Do the stars shimmering above us still exist at this very moment? Or is their light simply a collection of messages sent millions or even billions of years ago? What came before galaxies? Before our sun? Before time itself, as we understand it, ever began to flow? And could it be that by exploring the immense universe beyond us, we also come to understand something deeper about the universe within? Tonight, we will take a slow and peaceful journey through some of the most astonishing mysteries of astrophysics. Together, we'll discover why the universe is not standing still, but continues to expand. We'll see how light carries the history of time itself across unimaginable distances. We'll witness stars being born, living their extraordinary lives, and quietly fading away. We'll explore mysterious black holes that bend both space and time, and we'll follow the remarkable story of every atom within our own bodies. Atoms forged inside ancient stars billions of years before Earth itself came into existence. This is not a dry science lecture. Instead, it is a gentle voyage, where the discoveries of modern astrophysics intertwine with quiet reflections on what it means to be human. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "Who looks outside dreams, who looks inside awakes." Jung was reflecting on the human journey of psychological awareness and self-discovery, not on astronomy or cosmology. He believed that the symbols and experiences we encounter in the outer world can gently guide us toward a deeper understanding of the unconscious mind and the process of individuation. Perhaps that is why the night sky has always held such enduring power. It invites us to look outward toward the infinite, while the wonder it awakens quietly leads us inward. Throughout this journey, we will carefully distinguish between what science has discovered and the symbolic insights inspired by Jung's psychology. The universe will be told through the language of astrophysics. The human soul will be illuminated through the timeless symbols that Jung devoted his life to exploring. Welcome to our channel, a peaceful place where science, history, and the depths of the human mind come together. A place created for you to learn, to wonder, and to gently unwind before drifting into sleep. If you enjoy thoughtful journeys like this one, we would love to have you join us. Please consider subscribing, turning on notifications, and accompanying us on many more quiet explorations still to come. And now, find a comfortable position, take one slow, gentle breath, allow the thoughts of the day to gradually drift away. Then, together, lift your eyes toward the night sky, for perhaps, somewhere within that seemingly endless darkness, we will discover not only the story of the stars, but also some of the quietest, most beautiful pieces of ourselves. Part 1. A journey into the universe. As night gently settles in and the sounds of the day slowly fade into silence, the sky above us begins to reveal itself in a way that daylight rarely allows. One by one, the stars quietly appear, never in a hurry, never demanding attention, like countless tiny lanterns being lit across an endless ocean of darkness. In moments like these, it is easy to feel wonderfully small, yet it is within that very feeling of smallness that another door quietly opens, the door of curiosity. For thousands of years, human beings have looked up at the night sky and asked the same timeless questions. What are those distant points of light? Where did they come from? And within that vast, seemingly endless silence, is the universe trying to tell us a story? This is where astrophysics begins. Astrophysics is far more than the study of stars, planets, or galaxies. It is the search for the fundamental laws that govern the entire universe. By bringing together observational astronomy and physics, it seeks answers to some of humanity's greatest questions. How was the universe born? How do stars live? And how do they die? What bends space itself? Why can time flow at different rates? And ultimately, where do we fit within this immense cosmic picture? Perhaps the most astonishing discovery of all is that the universe is anything but still. If we could watch the cosmos over millions or even billions of years in only a few moments, we would witness a magnificent symphony of motion. Enormous clouds of gas collapse under gravity, giving birth to newborn stars. Ancient stars grow old, expanding into brilliant red giants, before ending their lives in spectacular supernova explosions. Galaxies collide, merge, and are reborn. Meanwhile, the space between galaxies continues expanding, carrying billions of them ever farther apart. To our eyes, the night sky seems almost unchanged from one evening to the next. But on the time scale of the universe, everything is moving, everything is changing, everything is continuing its story. That is why astrophysics does not study motionless objects. It studies processes, transformations unfolding across millions and billions of years. A star we observe tonight may already be vastly different from the moment its light first began its journey toward Earth. A distant galaxy may have completely changed its shape long before its image finally reaches our telescopes. And here we meet the first great character in tonight's journey: light. Light does far more than allow us to see the universe. It is the universe's most faithful storyteller. Every beam of light requires time to travel. Sunlight takes about 8 minutes to reach Earth, which means that whenever we look at the Sunday, we are seeing it as it was 8 minutes ago. The light from Sirius, the brightest star in Earth's night sky, takes more than 8 years to arrive. Meanwhile, the light from the most distant galaxies ever observed by modern telescopes began its journey over 13 billion years ago. In other words, astronomy is perhaps the only science in which every observation is also an observation of the past. We cannot travel backward through time, but light has done it for us. Every photon is like an ancient letter carrying information from the place where it was born. The color of light reveals a star's temperature. Its spectrum uncovers its chemical composition. Tiny shifts within those spectral lines reveal the speed at which a galaxy is moving. Simply by studying unimaginably faint rays of light, astronomers can determine which elements exist inside a star hundreds of light years away, how hot it is, whether it is young or old, and even whether planets may be orbiting around it. But if light is the storyteller, gravity is the author writing the universe's script. It is the invisible force that keeps planets circling the Sunday, holds stars together inside galaxies, and binds galaxies into enormous clusters stretching across the cosmos. According to Albert Einstein's theory of general relativity, gravity is not merely an attractive force. It is the curvature of space-time itself, created by matter and energy. Planets, stars, even light, all travel across that invisible cosmic fabric. And then there is one more quiet companion, present in every story the universe tells: time. We experience time as the steady rhythm of days passing into nights. Yet on the scale of the cosmos, time behaves in extraordinary ways. Near objects possessing immense gravity, clocks actually run more slowly, across unimaginable distances. Light allows us to witness events that happened billions of years ago. So whenever we gaze into the night sky, we are not simply looking across space. We are looking across many different moments in history, all existing together within a single view. Perhaps that is what makes astrophysics one of the most poetic sciences ever created. It teaches us that the heavens are not a silent dome suspended above us. They are an immense chronicle, written with light, gravity, and time. Every star is a chapter, every galaxy, an entire library, every ray of light, a line of writing still crossing the vastness of space on its way toward our eyes. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "Who looks outside dreams. Who looks inside awakes." Jung was reflecting on psychological awareness and the journey towards self-understanding not on astrophysics. He believed that the outer world often becomes a symbolic mirror through which we gradually come to know the deeper dimensions of our own minds. Perhaps that is why looking up at a sky filled with stars feels so profoundly moving. We dream about distant galaxies, about black holes, about the origin of time, and the ultimate fate of the universe. Yet strangely, the farther we travel into the vastness above us, the more gently we are invited to return to ourselves. The immensity of the cosmos makes our everyday worries feel a little smaller. The patience of the stars reminds us that not every question needs an immediate answer. And light, which has traveled for billions of years simply to reach us tonight, becomes a beautiful symbol that every meaningful journey requires time. Tonight is only the beginning. Ahead of us lie the stories of the birth of the universe, the first stars, the mysterious nature of black holes, the invisible presence of dark matter, and the galaxies that continue drifting farther and farther apart through an endless cosmos. So allow your body to relax a little more. Let each breath become slower and gentler. Allow your thoughts to drift alongside those ancient rays of light that are still quietly crossing the universe. For perhaps, somewhere within our journey through the infinite night sky, we may also discover one of the quietest corners of our own souls. Part 2. The Birth of the Universe. If last night we looked up at a sky filled with stars and began wondering about the story that light is telling, then tonight, let us travel even farther, far beyond the nearest galaxies, beyond the immense clusters of galaxies, beyond the very first stars that ever shone in the primordial darkness. Together, we will journey back to a time when nearly every concept familiar to us, space, time, matter, and light, had only just begun to exist. This is not a voyage aboard a spacecraft. It is a journey of imagination, guided by the remarkable discoveries of modern astrophysics. When most people hear the words Big Bang, they picture an enormous explosion erupting into an already existing emptiness, like a spectacular firework sending everything flying outward in every direction. It is an understandable image, but according to modern cosmology, it is not quite what happened. The Big Bang was not an explosion that occurred within space, because at that moment, space itself was coming into existence. There was no vast empty void waiting for the universe to expand into. Instead, space-time itself began expanding from an extraordinarily hot, extraordinarily dense, and unimaginably tiny state. Every location in the universe participated in that expansion simultaneously. There was no center, no preferred direction. Every point experienced space itself stretching all around it. It is a wonderfully strange idea, and a profoundly beautiful one. It means that every galaxy we see today, including our own Milky Way, shares the imprint of one common beginning. During the tiniest fraction of the first second after the Big Bang, the universe reached temperatures beyond anything we can truly imagine. The energy was so immense that atoms could not yet exist. Even protons and neutrons had not formed into stable particles. Everything resembled a brilliant ocean of fundamental particles and radiation, moving ceaselessly within an environment of extraordinary density. This was the infant universe. There were no planets, no stars, no skies, no darkness, only energy, elementary particles, and the laws of physics beginning to shape the destiny of the cosmos. One of the most important ideas in modern cosmology is known as cosmic inflation. According to this model, during an unimaginably brief instant after the universe came into being, space expanded at an astonishing rate, far faster than the expansion that followed throughout cosmic history. Imagine the entire universe as something smaller than a grain of dust, in less than a heartbeat. That tiny beginning expanded to an immense scale. Cosmic inflation does more than explain why today's universe appears remarkably uniform in every direction. Even more importantly, it magnified tiny quantum fluctuations into slight differences in the density of matter. At first glance, those fluctuations were almost insignificant, yet they became the very first seeds of every galaxy, every star, every planet, and ultimately, every living thing. It is extraordinary to think that all the beauty filling tonight's sky may have originated from ripples so unimaginably small they almost defy comprehension. As the universe continued expanding, its temperature gradually cooled. Then, about 380,000 years after the Big Bang, a pivotal moment arrived. Free electrons finally combined with protons to form the first stable hydrogen atoms. This event is known as recombination. For the first time, light was no longer scattered continuously by charged particles. Instead, it became free to travel across space. That ancient light still exists today. After nearly 14 billion years of cosmic expansion, it has cooled dramatically and now fills the universe as the cosmic microwave background. Often called the CMB, you might think of the CMB as the universe's childhood photograph. Whenever radio telescopes observe this faint glow, they are not simply detecting a weak signal from space. They are witnessing the oldest light humanity has ever observed, a message that began its journey before even a single star had appeared. Once that first light was released, the universe entered a remarkable period, known as the Dark Ages. Its name may sound mysterious, or even frightening, yet in reality, it was simply an era of extraordinary quiet. Neutral hydrogen filled nearly all of space. No stars yet burned brightly enough to illuminate the heavens. The universe rested in a gentle darkness that endured for tens of millions of years. It was the calm before the symphony of stars began. Eventually, gravity slowly gathered enormous clouds of gas together. The first stars were born. Their brilliant light began ionizing the surrounding hydrogen once again. Astronomers call this period the epoch of reionization. Gradually, the once dark universe filled with light. The first galaxies emerged. The cosmos slowly acquired the appearance we recognize today. Perhaps the most astonishing realization is that this entire magnificent structure, from galaxy superclusters stretching across billions of light years, to the Milky Way, to our own solar system, can ultimately be traced back to those tiny quantum fluctuations present in the earliest moments of the universe. Over billions of years, gravity patiently amplified those minute differences into the vast interconnected structure astronomers now call the cosmic web. It is difficult not to feel a sense of wonder. Differences so small they were almost invisible, eventually created everything magnificent we see today. Carl Gustav Jung once wrote in The Archetypes and the Collective Unconscious, in addition to our immediate consciousness, which is of a thoroughly personal nature, there exists a second psychic system of a collective, universal, and impersonal nature, which is identical in all individuals. Jung was writing about the collective unconscious and the universal structures of the human psyche, not about the Big Bang or the evolution of galaxies. He proposed that beneath our individual awareness lies a deeper psychological foundation shared by all humanity. Viewed symbolically, however, his insight offers a beautiful parallel. Just as today's universe grew from almost imperceptible fluctuations in its earliest moments, our inner lives are quietly shaped by invisible depths that often remain beyond conscious awareness. Tiny seeds of experience, memory, and symbol gradually unfold across the years, until one day they influence how we see the world, how we love, how we create, and how we grow. And now, as the night continues, embracing the sky above us, imagine that the light reaching your eyes at this very moment began its journey when the universe itself was still astonishingly young. Every star you see is the result of billions of years of patient transformation. And perhaps, just as the universe continues expanding from the smallest of beginnings, every quiet thought within the human heart is also slowly growing into something far greater, in ways that only time itself can fully reveal. So let your mind continue drifting gently through that boundless cosmos, for ahead of us still lie many more stories, patiently waiting to be told. By the light of the universe itself. Part 3. The expanding universe. If, in our previous journey, we traveled back to the moment when the universe first found its voice, then, tonight, let us quietly turn our attention to what is happening right now. For there is a remarkable truth that our eyes cannot perceive within the span of a single human lifetime. The universe has never been still. When we look up at the night sky, the familiar constellations seem unchanged. The Milky Way still stretches across the heavens like a luminous river. Even the distant galaxies captured in astronomical photographs appear like motionless islands floating in an endless sea of darkness. But that peaceful stillness exists only on the timescale of human life, across millions and billions of years. The entire universe is participating in a vast cosmic motion. Galaxies are not simply sailing through space like ships crossing an ocean. Instead, the very space between them continues to expand. At first, this idea feels almost impossible to picture. How can empty space itself expand? We often imagine space as a fixed stage upon which stars and galaxies perform their movements. Modern physics tells a different story. Space is not a rigid box. It is more like an invisible fabric, one that can stretch, curve, and evolve with time. Imagine the surface of a balloon as it is slowly being inflated. Tiny dots drawn on the balloon do not crawl across its surface. Yet as the balloon grows larger, every dot becomes farther from every other dot. No single dot is the center of the expansion. From the perspective of each one, all the others appear to be moving away. Galaxies behave in much the same way. Space expands, and the galaxies are gently carried along with it. This revolutionary discovery began to emerge in the early 20th century, when astronomer Edwin Hubble observed that most galaxies were moving away from us. Even more astonishing, the farther away a galaxy is, the faster it appears to recede. The evidence for this extraordinary phenomenon is written into the light itself. Astronomers call it redshift. When a source of light moves away, its wavelengths become stretched, shifting its spectral lines toward the red end of the spectrum. It is similar to the sound of a train moving into the distance, whose whistle becomes lower in pitch because of the Doppler effect. In astronomy, light becomes both a ruler and a messenger. Simply by examining tiny shifts within spectral lines, scientists can determine whether a galaxy is approaching or receding, and even estimate the speed of that motion. It is astonishing to realize that from faint rays of light traveling across billions of light years, humanity has learned to perceive the very breathing of the universe. Yet the story reaches even farther. If space continues expanding, what awaits the universe in the unimaginably distant future? The answer is both beautiful and quietly bittersweet. Galaxies will drift ever farther apart. Their light will require longer and longer to reach us. Some galaxies will eventually recede so rapidly that newly emitted light from them will never overcome the expansion of space. It will never arrive at Earth. This idea leads us to one of cosmology's most fascinating concepts, the cosmic horizon. It is not a wall, not the edge of the universe. Rather, it marks the limit of what light is still able to reveal to us. Beyond that horizon may lie countless galaxies, vast cosmic structures, and immense regions of space that remain forever unseen. But their light has either not had enough time to reach us, or never will, because the expansion of space carries them away too quickly. This means that what humanity observes is not the entire universe. We see only the observable universe. Imagine standing on the shore of an immense ocean wrapped in dense morning fog. You know the sea stretches far beyond the horizon, yet you can see only as far as your eyes allow. Perhaps this is one of astronomy's most beautiful lessons. Not everything that exists can be seen. Not every limit we encounter is a limit of reality itself. Sometimes, it is simply the limit of observation. If hundreds of billions of years continue to pass, the night sky will become profoundly different. Galaxies beyond our local group will gradually disappear from view. Astronomers living in that unimaginably distant future may see only a single enormous galaxy formed from the merger of the Milky Way and Andromeda. They may never know that hundreds of billions of other galaxies once filled the cosmos. Not because those galaxies vanished, but because their light could no longer reach them. It is a strangely moving thought. The night sky of the far future may become quieter than the one we know tonight. Fewer galaxies, less light, greater silence. Yet the universe will continue expanding, patiently, and without end. Carl Gustav Jung once wrote in Iron, researches into the phenomenology of the self. The self is not only the center, but also the whole circumference, which embraces both conscious and unconscious. It is the center of this totality, just as the ego is the center of consciousness. Jung was describing the psychological concept of the self, the totality of the conscious and unconscious mind, not the expansion of the universe. His work explored how much of our inner life extends beyond ordinary awareness and gradually reveals itself through the lifelong process of individuation. Viewed symbolically, however, his words offer a beautiful parallel. Just as the universe extends far beyond what our eyes are able to observe, our inner lives are always larger than the small portion we consciously experience each day. There are memories, possibilities, symbols, and emotions that still lie beyond our own personal horizon. They have not disappeared. They are simply waiting for the right moment to be discovered. Perhaps that is one of the deepest beauties shared by both the universe and the human soul. Both are greater than they first appear. Both continue changing without ceasing, and both gently remind us that true expansion is not always about traveling farther outward. Sometimes, it is about expanding our capacity to understand. And now, as night continues settling across the heavens, imagine that every star you see is carrying a story that began long before humanity first walked upon the earth. Some of those stories are still making their way toward us. Others are slowly drifting beyond our reach forever. Yet together they compose the quiet symphony of the cosmos. And perhaps, within that endless expansion, we are reminded that life itself is always moving, understanding is always capable of growing, and every horizon of knowledge will forever lie just a little farther than where we stand today. So allow your thoughts to drift gently with the expanding universe, like a quiet star becoming part of the infinite night, where every journey continues, slowly, across immeasurable distances, in perfect peace. Part 4. Light, the astronomer's time machine. As the night grows deeper, the sky seems to become even more profound. The stars continue shining quietly, just as they have for millions of years, never in a hurry, never calling attention to themselves. They simply send delicate streams of light across the immeasurable darkness toward Earth. To our eyes, they appear as tiny points sparkling against the blackness. But to an astronomer, every beam of light is a story, a message, and a fragment of the universe's memory. Perhaps the most extraordinary thing about light is this: it never tells us about the present. Light always carries the past. Even though light travels at nearly 300,000 kilometers per second, it still requires time to journey from where it was born to the place where it is observed. Sometimes that journey lasts only minutes, sometimes billions of years, which means that every time we look up at the night sky, we are not truly seeing the universe as it exists right now. We are witnessing what once existed. Sunlight takes about 8 minutes to reach Earth, so whenever you feel the warmth of the morning sunshine upon your skin, you are touching the sun as it was 8 minutes ago. The light from Sirius takes more than 8 years to arrive. The light from the Andromeda galaxy began its journey roughly 2.5 million years ago, when humanity's distant ancestors had not yet built civilizations upon the Earth. And the most distant galaxies ever observed by the James Webb Space Telescope are sending us light that began traveling more than 13 billion years ago, when the universe itself was still remarkably young. It is a beautiful thought. Astronomy may be the only science in which every observation is also a journey backward through time. Humanity has not yet built a time machine, but nature quietly created one. At the dawn of the universe, it is called light. Every photon is like a patient messenger. It carries the story of the place where it was born, crossing almost empty space, passing through clouds of gas, traveling beyond galaxies, and enduring billions of years, simply to arrive at a small telescope here on Earth. And the moment we receive that tiny messenger, another page of the universe's history quietly opens before us. Yet the wonder of light extends far beyond its journey through time. Light also carries the identity of the stars themselves. When white light passes through a prism, it separates into many different colors: red, orange, yellow, green, blue, and violet. Astronomers call this a spectrum. At first glance, it looks like nothing more than a beautiful rainbow. But to science, it is an extraordinarily detailed record. Every chemical element in nature absorbs and emits light at its own unique wavelengths. Those interactions create distinctive dark or bright lines within the spectrum. Just as every person has unique fingerprints, every element possesses its own unmistakable fingerprint of light. Simply by studying those tiny spectral lines, scientists can determine whether a distant star contains hydrogen, helium, carbon, oxygen, iron, or many other elements, even when that star lies thousands of light years away. It is astonishing to realize that we never need to touch a star in order to understand it. We simply need to listen to the light it sends us. Light also reveals a star's temperature. Stars glowing red are generally cooler, with surface temperatures of only a few thousand degrees Celsius. Blue stars, by contrast, are vastly hotter, sometimes exceeding 30,000 degrees Celsius. What our eyes perceive simply as beautiful color is actually the language of physics. Every color is a number. Every shade is information. Every ray of light is speaking. Light even tells us how galaxies move through the universe by means of the Doppler effect. When a galaxy moves toward us, its wavelengths become compressed, shifting its light toward the blue end of the spectrum. When it moves away, the wavelengths stretch, shifting toward red. From these incredibly subtle changes in color, astronomers can calculate whether a galaxy is approaching or receding, and determine its speed. From just a few kilometers per second to tens of thousands. It is remarkable to realize that light tells us more than what an object is. It also tells us where that object is going. Through these quiet messages, humanity gradually discovered that the universe is expanding, that stars evolve, and that galaxies participate in a magnificent cosmic symphony unfolding across billions of years. Perhaps light is the most patient storyteller nature has ever created. It never rushes. It never exaggerates. It never judges. It simply carries the truth of where it came from. Carl Gustav Jung once wrote in Symbols of Transformation, "The symbol is the expression of an unknown fact, a fact that is nevertheless recognized or postulated as existing." Jung was writing about the symbolic language of the human psyche, not about photons, spectroscopy, or the Doppler effect. He believed that symbols reveal deeper psychological realities that cannot always be understood directly, but nevertheless shape our inner lives in profound ways. Viewed symbolically, his words resonate beautifully with the work of astronomy. Light itself is like a symbol. Before we learn to interpret it, it appears to be nothing more than a tiny point shining in the night. Yet hidden within that small point lies an entire world invisible to ordinary sight. Only after humanity learned to read the language of light did those unseen worlds gradually reveal themselves. Perhaps the human mind is much the same. Many thoughts, emotions, and memories do not arrive as clear answers. Instead, they come to us through symbols, dreams, quiet intuitions, like light arriving from a star unimaginably far away. To understand them, we must be patient. just as astronomers patiently study every delicate spectral line in order to discover the true nature of a distant sun millions of light years away. And now, as night continues wrapping the heavens in gentle darkness, imagine that every ray of light reaching your eyes began its journey at a different moment in the history of the universe. Some left the sun only minutes ago. Others began traveling long before human beings ever walked the earth. Yet all of them arrived together, in this single quiet moment, like ancient pages from countless books opening at once. And perhaps, just as light requires time to carry the stories of the stars to us, the experiences of our own lives also need time before their deepest meanings become clear. So let your thoughts drift gently alongside those ancient rays of light. For ahead of us still wait many more wonders, both in the vastness of the night sky and within the quiet universe of the human soul. Part 5. Gravity and space-time. Perhaps among all the extraordinary discoveries of astrophysics, few ideas inspire as much wonder and as much reflection as the relationship between gravity and space-time. From childhood, most of us learn that gravity is simply the invisible force that pulls things downward. An apple falls from a tree. Raindrops return to the earth. The moon circles our planet. The earth travels around the Sunday. It all seems to happen because an unseen force is drawing objects toward one another. Then, at the beginning of the 20th century, Albert Einstein transformed humanity's understanding of the universe. He did not reject gravity. Instead, he revealed that its true nature is even more astonishing. According to the theory of general relativity, what we call gravity is not an invisible rope pulling objects together. Rather, matter and energy bend the very fabric of space-time itself. Planets, stars, and galaxies simply move along the natural curves created within that invisible fabric. Imagine a perfectly stretched sheet. Place a heavy ball upon it, and the surface sinks beneath its weight. Now roll a small marble across the sheet. The marble is not being pulled toward the larger ball in the ordinary sense. It is simply following the curved surface beneath it. Space-time behaves in much the same way. The planets are not being dragged around the sun by invisible strings. They are traveling along paths created by the curvature of space-time itself. The beauty of this idea lies not only in its mathematical elegance, but also in how profoundly it changes the way we see reality. Space and time, once thought to be rigid and unchanging, turn out to be far more graceful. They can bend, stretch, ripple, and respond to the presence of matter. And if space-time can bend, then time itself is no longer absolute. In everyday life, every second seems to pass at exactly the same pace. The clock in one room appears to tick in perfect rhythm with a clock somewhere else. But on the scale of the universe, that is not entirely true. Einstein showed that time passes more slowly near objects with immense mass. This phenomenon is known as gravitational time dilation. Near a neutron star or a black hole, a clock runs more slowly than one located far from such powerful gravity. This is not merely a theoretical idea. Today, the satellites that make up the Global Positioning System, GPS, must constantly correct for relativistic effects in order to maintain their remarkable accuracy. Without accounting for the tiny difference in the passage of time between Earth's surface and orbit, navigation errors would steadily grow larger every day, even when we do not notice it. We are living inside a universe where time does not always flow at the same rhythm. More than a century after Einstein introduced general relativity, another breathtaking discovery emerged: gravitational waves. Imagine a perfectly still lake. Drop a pebble into the water, and gentle ripples spread outward in every direction. In much the same way, when two enormous black holes spiral together and merge, or when two neutron stars collide, space-time itself begins to ripple. Those waves travel across the universe. They are unimaginably small. By the time they pass through Earth, they change the distance between 2 points by less than the diameter of a single proton. And yet, in 2015, The LIGO observatory made the first direct detection of gravitational waves, confirming a prediction Einstein had made nearly 100 years earlier. It was more than a scientific achievement. It was as though humanity had learned, for the very first time, to hear the vibrations of space-time itself. If light became the eyes of astronomy, gravitational waves have become its ears. Gravity influences not only time, but light itself. For centuries, people believed that light always traveled along perfectly straight paths. General relativity revealed something different. When light passes near an object of enormous mass, its path bends because space-time itself is curved. This phenomenon is known as gravitational lensing. In 1919, during a total solar eclipse, astronomers confirmed that the apparent positions of stars behind the Sun shifted by exactly the amount Einstein had predicted. It became one of the earliest and most convincing confirmations of general relativity. Sometimes this bending creates some of the most beautiful images in all of astronomy. An enormous galaxy in the foreground can act like a natural magnifying glass, bending and amplifying the light from galaxies lying far behind it. Because of this extraordinary phenomenon, astronomers are able to observe galaxies so faint and so distant that, without nature's own cosmic lens, they would remain invisible. Another fascinating truth is that gravity does not act instantaneously. Imagine, purely as a thought experiment, that the Sun were suddenly to disappear. Such an event is physically unrealistic, but it helps illustrate an important idea. Earth would not feel the change immediately. Both sunlight and the change in the Sun's gravitational influence would require about 8 minutes to reach us. This tells us that changes in gravity propagate at the speed of light, exactly as general relativity predicts. The universe, then, is not a rigid machine. It is more like a magnificent symphony. Every motion requires time to travel. Light and gravity work together, quietly connecting regions of space separated by millions, or even billions, of light years. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "The meeting of two personalities is like the contact of two chemical substances. If there is any reaction, both are transformed." Jung was reflecting on human relationships and psychological transformation, not on gravity or the curvature of space-time. His insight explored how meaningful encounters reshape the inner lives of everyone involved. Viewed symbolically, however, his words offer a beautiful parallel. Human beings resemble celestial bodies in one remarkable way. Every meeting, every relationship, every experience quietly reshapes the landscape of our inner world. Some people enter our lives almost unnoticed, yet their presence gently changes the trajectory of our thoughts, our feelings, and the path of our personal growth. Just as a massive star bends the space-time surrounding it, deeply meaningful experiences can quietly reshape the way we see the world, without dramatic upheaval or noise. Perhaps this is one of the greatest beauties shared by both science and psychology. Both remind us that the most important realities are often invisible. They exist within unseen forces, subtle influences, and delicate connections unfolding every moment. And now, as you gently close your eyes beneath tonight's peaceful sky, imagine that the space-time surrounding you is quietly curving beneath the presence of the Earth, the Moon, the Sunday, and countless distant galaxies. Everything continues moving within a vast cosmic symphony. Every gravitational ripple, every beam of light, every passing moment helps carry forward the endless story of the universe. And perhaps, just as space-time quietly connects every celestial body, the experiences of your own life are also quietly connecting, shaping the person you are gradually becoming. Part 6. Dark Matter and Dark Energy. There are nights when the sky is so clear that the Milky Way stretches overhead like a river of silver silk across the darkness. In moments like these, it is easy to believe that we are seeing the full beauty of the universe. thousands of shimmering stars, faint glowing nebulae, countless distant galaxies. It seems as though the heavens have revealed all of their secrets. Yet the deeper astronomers have looked, the more humbling a truth they have discovered. The universe revealed by light is only a very small fraction of everything that truly exists. It is like walking into a forest, wrapped in the mist of early morning. Your eyes can see only the nearest trees. Beyond the veil of fog, an entire forest still surrounds you. The universe is much the same. Everything we observe through telescopes, stars, planets, nebulae, even enormous galaxies, accounts for only about 5% of the universe's total matter and energy. The remaining 95% belongs to two of modern physics' greatest mysteries: dark matter and dark energy. The name dark matter sometimes suggests a black substance or a special kind of darkness. In reality, the name simply means that we cannot see it with light. Dark matter neither emits, reflects, nor absorbs light in ways our telescopes can detect. It is, for all practical purposes, invisible, yet invisibler. Does not mean non-existent. We know dark matter exists because of its gravity. During the 1970s, astronomer Vera Rubin carefully measured how spiral galaxies rotate. Based only on the visible matter they contain, stars near the outer edges of galaxies should orbit much more slowly than stars near the center. It is similar to how the outer planets of our solar system move more slowly around the sun than the inner planets do. But that is not what she found. The stars near the edges of galaxies continued orbiting astonishingly fast. So fast, in fact, that if only the visible matter were present, those galaxies should have torn themselves apart billions of years ago. The only explanation was that each galaxy contains an enormous amount of unseen matter, like an invisible wind revealed only by the movement of leaves. Dark matter reveals itself through its gravitational influence. Today, cosmologists believe that every galaxy is surrounded by an immense halo of dark matter. It is this invisible framework, this hidden skeleton, that has held galaxies together for billions of years. The evidence for dark matter extends far beyond individual galaxies. When astronomers study galaxy clusters, vast collections containing hundreds or even thousands of galaxies, they find the same mystery. The visible mass simply is not enough to keep those enormous structures bound together. Even more remarkably, through the phenomenon of gravitational lensing, light from distant galaxies bends far more than visible matter alone can account for. Something unseen and immensely massive must also be present. If dark matter forms the hidden framework of the universe, then on even larger scales, it creates one of the most beautiful structures known to astronomy, the cosmic web. Imagine an unimaginably vast spider's web stretching across the cosmos. Along its delicate filaments lie galaxies and galaxy clusters gathered into enormous strands. Between those strands exist immense regions where almost no galaxies are found. These enormous empty regions are known as cosmic voids. At first glance, they appear almost completely empty. Yet, even that emptiness helps shape the architecture of the universe. Just as silence gives greater beauty to a piece of music, the great cosmic voids reveal the elegance of the vast galactic networks surrounding them. If dark matter holds cosmic structures together, dark energy appears to do the opposite. Near the end of the 20th century, astronomers studying extremely distant supernovae made a startling discovery. They expected gravity to slow the universe's expansion over time. Instead, they found exactly the opposite. The expansion of the universe is accelerating. Something unseen is quietly causing space itself to expand faster and faster. This mysterious influence is called dark energy. To this day, no one knows its true nature. It does not shine. It cannot be touched. It cannot be observed directly. Yet its effects are shaping the future of the entire universe. If our current cosmological models are correct, then tens of billions of years from now, galaxies will continue drifting ever farther apart. Stars will gradually exhaust their nuclear fuel. The birth of new stars will slow and eventually become exceedingly rare. The night sky will grow darker with every passing cosmic age. Cosmologists call this possible future the heat death of the universe. Not a violent explosion, not a catastrophic collapse, but an almost endless silence. A colder universe, a darker universe, a lonelier universe. One in which energy becomes increasingly spread out until organized processes slowly come to an end. At first, the idea may sound melancholy, yet it also offers a gentle reminder. Everything in the universe moves according to the rhythm of time. Even galaxies that endure for billions of years remain part of an ever-changing cosmos. Carl Gustav Jung once wrote in Modern Man in Search of a Soul, "Until you make the unconscious conscious, it will direct your life, and you will call it fate." Jung was writing about the unconscious mind and psychological awareness, not about dark matter or dark energy. His point was that unseen psychological forces can quietly influence our choices and experiences until we gradually become aware of them. Viewed symbolically, however, his insight echoes something deeply meaningful about the universe itself. Just as most of the cosmos is shaped by components invisible to our eyes, our inner lives are profoundly influenced by layers of the psyche that remain outside ordinary consciousness. We are usually aware only of the luminous part of the mind, our conscious thoughts, our deliberate choices, and the emotions we can easily name. Beneath them lie memories, patterns, symbols, and quiet motivations that influence how we choose, how we love, what we fear, and how we grow. Perhaps astrophysics and psychology meet most beautifully in this shared lesson. The most important realities are not always the easiest to see. Invisible forces can shape an entire galaxy. Invisible movements within the unconscious can quietly shape an entire human life. And just as astronomers patiently trace the existence of dark matter through the motions of stars, each of us can patiently observe the subtle patterns within our own inner world, learning, little by little, to understand ourselves more deeply. Now, as the night grows quieter and the stars continue their silent radiance overhead, allow your imagination to drift across the immense cosmic web. Perhaps, within what first appears to be empty space, we discover the unseen forces that have quietly supported the universe, and perhaps our own souls, all along. Part 7. The Life and Death of Stars. If the universe is an endless symphony, then the stars are its brightest notes. Each star has its own story, its own journey, its own destiny. They are born in the almost perfect stillness of space, live for millions or even tens of billions of years, and quietly complete their lives in ways that are both breathtaking and deeply poetic. Perhaps the most remarkable truth of all is this: every carbon atom in our bodies, every breath of oxygen we take, every trace of calcium within our bones, was once forged inside ancient stars. Before we became human, we were part of the stars. That story begins within enormous molecular nebulae, vast clouds of cold gas and dust, stretching across dozens, sometimes even hundreds, of light years. From afar, they resemble delicate ribbons of mist drifting silently through the darkness. But deep within them, gravity never rests. Tiny grains of dust, individual hydrogen atoms, slowly draw together. Across millions of years, more and more matter accumulates. The growing cloud becomes denser, hotter, until, at its heart, the embryo of a new star is born. When the temperature in the core reaches roughly 10 million degrees Celsius, something extraordinary happens. Hydrogen nuclei begin fusing into helium through nuclear fusion. A tiny fraction of their mass is transformed into energy, according to Einstein's famous equation, A/m². That energy radiates outward as heat and light. and in that moment, a star truly comes to life. From then on, the life of a star becomes a delicate yet enduring balance between two opposing forces. Gravity continually tries to collapse all of the star's matter inward. The pressure created by nuclear fusion continually pushes outward. As long as those two forces remain in balance, the star continues shining. That is the secret of our own Sunday. For nearly 4.6 billion years, the sun has not burned like an ordinary fire. It consumes neither oxygen nor chemical fuel. The sunlight that greets us every morning comes from trillions upon trillions of nuclear fusion reactions taking place every second deep within its core. Each second, roughly 600 million tons of hydrogen are transformed into helium. A small portion of that mass becomes energy. That energy then spends hundreds of thousands of years slowly making its way from the sun's core to its surface, before requiring another 8 minutes to reach Earth. The sunlight touching your face today began its journey deep inside the sun long before it ever escaped into space. Yet not every star follows the same path. Red dwarfs are small, cool stars that consume their fuel with extraordinary efficiency. They may survive for trillions of years, far longer than the current age of the universe itself. Blue stars, however, are their complete opposite. They possess enormous masses, surface temperatures exceeding 30,000 degrees Celsius, and they radiate with an intense blue-white brilliance. Because they consume their nuclear fuel so rapidly, they live for only a few million years, a mere blink of an eye on the cosmic timescale. Mass determines the destiny of every star. As massive stars age, they expand into red giants or even supergiants. Within their cores, nuclear fusion continues, creating heavier and heavier elements: carbon, oxygen, neon, silicon, and finally, iron. But iron marks the end of the journey. Fusing iron no longer produces the energy needed to resist gravity. When that moment arrives, the stellar core collapses in an instant. Then, the universe erupts with light. A supernova is born. For a few brief days, a single supernova can outshine an entire galaxy containing hundreds of billions of stars. Within these magnificent explosions, gold, silver, uranium, and many other heavy elements are created before being scattered into space. Those atoms will later become part of new generations of stars, new planets, and eventually, new life. In that sense, the death of a star is also a gift to the future. If a star begins with a mass similar to our sun's, then after its outer layers drift away, its remaining core becomes a white dwarf. Although only about the size of Earth, it contains nearly the mass of the Sunday. No longer sustained by nuclear fusion, it simply radiates its remaining heat for billions of years. In a future so distant it lies beyond imagination, white dwarfs will eventually cool completely, becoming what physicists call black dwarfs. Interestingly, the universe is not yet old enough for even a single white dwarf to have cooled into one. Black dwarfs remain entirely theoretical, silent inhabitants of a future that has not yet arrived. Stars with much greater masses meet a different fate. After the supernova, the remaining core becomes compressed so intensely that protons and electrons merge together to form neutrons. The result is a neutron star, only about 20 kilometers across, yet capable of containing more mass than our Sunday. A single teaspoon of neutron star material, if it could somehow be brought safely to Earth, would weigh billions of tons. Some neutron stars rotate extraordinarily rapidly while emitting narrow beams of radio waves. Like cosmic lighthouses sweeping through the darkness, these objects are known as pulsars. Certain pulsars spin hundreds of times every second, with a precision exceeding that of many atomic clocks. Others possess magnetic fields so powerful that they surpass almost anything else known in nature. These are called magnetars. Their magnetic fields are trillions of times stronger than Earth's. If one were to exist dangerously close to our planet, its magnetic field could alter the very structure of atoms. Fortunately, every known magnetar lies safely far away from Earth. When we contemplate the lives of stars, it becomes difficult not to notice that the universe has never treated death as an absolute ending. One star completes its journey, so that others may begin theirs. The atoms forged inside the heart of an ancient sun continue traveling through the cosmos, linking generation after generation of celestial worlds across billions of years. Carl Gustav Jung once wrote in Symbols of Transformation, "There is no coming to consciousness without pain." Jung was writing about psychological transformation, not about stellar evolution. His point was that genuine self-awareness often emerges through difficult inner experiences rather than through comfort alone. Viewed symbolically, however, his words resonate beautifully with the lives of stars. A massive star creates its most precious elements only during the dramatic final stages of its existence. Likewise, many of the deepest transformations in human life arise not during peaceful seasons, but while moving through loss, challenge, or moments that compel us to change. This is not a celebration of suffering. Rather, it is a gentle reminder that even difficult chapters can become the place where a wiser, more mature, and more compassionate self quietly begins to take shape. Perhaps that is why, when we look up at a sky filled with stars, we are seeing far more than distant points of light. We are witnessing an endless cycle of birth, transformation, and renewal. Every star tells a story of balance, of patience, of the quiet beauty found in continual change. And as the night grows stiller around you, allow your thoughts to settle into that same rhythm. For perhaps, just as stars never truly disappear but simply become something new, every experience in our own lives is also quietly becoming the precious material from which a deeper, broader, and more awakened self will one day emerge. Part 8. Black holes, the regions of no return. Perhaps among all the wonders hidden within the universe, nothing inspires more awe or more imagination than a black hole. Even the name itself awakens countless images. A bottomless abyss that swallows everything. A doorway leading somewhere from which nothing has ever returned. A realm of absolute darkness lying beyond every familiar law of nature. For decades, black holes have appeared throughout literature, cinema, and human imagination as symbols of mystery. Yet the remarkable truth is this: as science has gradually drawn closer to them, reality has proved even more fascinating than fiction. The first thing to understand is that a black hole is not literally a hole in space. It is a region of space-time where matter has been compressed to such extraordinary density that gravity becomes so intense that nothing can easily escape. If our sun could somehow be compressed into a sphere only about 6 kilometers in radius, it would become a black hole, not because it transformed into some mysterious portal, but because the curvature of space-time surrounding it would become unimaginably extreme. Yet the most astonishing feature of a black hole is not its center, the region we call the singularity. Modern physics still cannot fully describe what truly happens there. Far more important is the invisible boundary surrounding it, the event horizon. It is not a physical wall. No glowing line marks its edge. If you could somehow drift across it, in theory, you would feel no sudden collision. And yet, the event horizon is one of the most profound boundaries in all of nature. Beyond it, every possible path through space-time leads inward, toward the heart of the black hole. Once light crosses that boundary, it can never return. A black hole does not pull light inward in the ordinary sense. Rather, the geometry of space-time itself removes every possible path of escape. Not all black holes remain motionless. In fact, most are believed to rotate. These rotating black holes, known as Kerr black holes, possess one of the strangest phenomena predicted by Einstein's general relativity. When an enormously massive object spins rapidly, it does more than curve space-time. It actually drags space-time along with its rotation. Physicists call this phenomenon frame dragging. Imagine stirring a spoon through a cup of honey. The honey nearest the spoon begins swirling with it. Space-time around a rotating black hole behaves in a remarkably similar way. it no longer remains perfectly still. Instead, it is drawn into an immense cosmic whirlpool. Surrounding the event horizon of a rotating black hole lies another extraordinary region known as the ergosphere. Within this region, space-time is dragged so powerfully that nothing can remain stationary with respect to the distant universe. Everything is compelled to rotate alongside the black hole. Remarkably, physicists have shown that, in principle, some of the black hole's rotational energy could be extracted from this region through a process known as the Penrose process. Even in one of the harshest environments imaginable, nature continues to obey elegant and consistent laws. For many years, scientists believed that black holes were completely black and would exist forever. Then, during the 1970s, physicist Stephen Hawking proposed an idea that forever changed our understanding of them. According to quantum mechanics, empty space is never truly empty. Tiny pairs of particles and antiparticles continually appear and disappear within unimaginably short intervals. Near the event horizon, quantum effects may allow one particle to fall into the black hole while its partner escapes. To a distant observer, it appears as though the black hole itself is emitting radiation. This remarkable prediction is known as Hawking radiation. To this day, Hawking radiation has never been observed directly because it is extraordinarily weak for astrophysical black holes. Yet, theoretically, it leads to a beautiful conclusion. Black holes are not completely eternal. Across spans of time so vast they defy imagination, they may slowly lose energy and eventually evaporate. In 2019, humanity witnessed the first image of a black hole. More precisely, we saw its shadow. Using a worldwide network of radio telescopes, known as the Event Horizon Telescope, astronomers revealed the image of the supermassive black hole at the center of the galaxy Messier 87, or M87. The glowing orange ring surrounding its dark center quickly became one of the defining scientific images of the 21st century. 3 years later, the same collaboration unveiled the first image of Sagittarius A, the supermassive black hole at the center of our own Milky Way, approximately 26,000 light-years from Earth. It is astonishing to realize that at the very heart of our galactic home lies a black hole containing roughly 4 million times the mass of our Sunday. Yet because it is so unimaginably distant, it poses no danger whatsoever to our solar system. It simply exists, quietly, like the immense and steady heart of the Milky Way. Supermassive black holes are not unique to our galaxy. Nearly every large galaxy appears to contain one at its center. When these enormous black holes consume surrounding matter at exceptionally high rates, the gas and dust spiraling inward become intensely heated, releasing extraordinary amounts of energy. The result is one of the brightest objects in the universe, a quasar. It is a beautiful paradox. One of the brightest lights in the cosmos is powered by one of its darkest places. Sometimes a star wanders too close to a supermassive black hole. The difference in gravitational force between the side nearest the black hole and the side farthest away becomes so extreme that the star is stretched apart and ultimately torn to pieces. Astronomers call this a tidal disruption event. Much of the stellar material eventually falls into the black hole. Some of it shines brilliantly before disappearing forever. Violent though these events are, they provide astronomers with rare opportunities to study regions of the universe that are otherwise almost impossible to observe. Carl Gustav Jung once wrote in Ion, "Researches into the phenomenology of the self. The confrontation with the unconscious is not a pathological process, it is a natural process." Jung was writing about the human unconscious and the psychological journey of self-discovery, not about black holes or event horizon. His work emphasized that exploring the unknown regions of the psyche is a natural part of becoming more fully aware of oneself. Viewed symbolically, however, the image of a black hole offers a striking parallel. Within Jungian psychology, each of us possesses inner regions that remain beyond conscious awareness. They are not places to fear or avoid, but places to approach with patience and curiosity. Just as astronomers cannot directly observe what lies beyond an event horizon, they learn about black holes by studying the subtle clues surrounding their edges. In much the same way, we often come to understand ourselves through dreams, emotions, intuitions, and the recurring patterns woven throughout our lives. The unknown is not necessarily something frightening. Sometimes, it is simply an invitation to explore. And now, as night settles ever more gently across the heavens, imagine that somewhere among the hundreds of billions of galaxies, countless black holes continue silently curving space-time. They emit no light, yet they have taught humanity some of its deepest lessons about gravity, about time, and about the nature of the universe itself. And perhaps, just as those mysterious regions are not merely symbols of disappearance, but gateways to new questions, the quiet, shadowed places within our own hearts are not endings either. Sometimes, it is precisely within the deepest silence and the greatest mystery that the most profound journey of understanding quietly begins. Part 9. The Milky Way and the large-scale structure of the universe. If stars are the quiet candles that illuminate the night, then galaxies are the great cities of the universe. Each galaxy is home to tens of billions, sometimes hundreds of billions, of stars, together with planets, nebulae, black holes, interstellar gas, and dust, all moving together in a cosmic dance that unfolds across billions of years. When we look into the night sky with our own eyes, we see only a faint band of light stretching across the darkness. For countless generations, people called it the Milky Way. Today we know that this gentle ribbon of light is only a tiny glimpse of our galactic home, one galaxy among hundreds of billions within the observable universe. One of the universe's quietest wonders is that galaxies did not appear immediately after the Big Bang. After the first stars were born, gravity patiently began gathering them together. Dark matter served as an invisible framework, creating gravitational cradles where gas and stars could slowly accumulate across hundreds of millions, and eventually billions, of years. Smaller systems merged together. Gradually, the first galaxies came into being. In other words, a galaxy is not created in a single moment. It grows, it matures, it gathers memories through countless encounters. That is why astronomers often speak of the evolutionary history of galaxies. Like living organisms, they change over time, except that their lives are measured not in decades, but in billions of years. Many people imagine galaxies as lonely islands drifting silently through empty space. Reality is far more dynamic. The universe is always in motion. Galaxies continually influence one another through gravity. They approach, pass by, and sometimes they collide in encounters lasting hundreds of millions of years. Remarkably, when two galaxies collide, the stars within them almost never strike one another directly. The distances separating individual stars are simply too immense. Instead, gravity reshapes the galaxies themselves. Their spiral arms stretch outward. New waves of star formation ignite, and over time, the two galaxies merge into one larger system. Even now, our own galaxy is part of this continuing story. The Milky Way has never been a fixed or unchanging system. Over billions of years, it has absorbed numerous smaller dwarf galaxies. One of the clearest examples is the Sagittarius dwarf galaxy, which is still being stretched apart by the Milky Way's gravity as it gradually becomes part of our galaxy. The long streams of stars arching across the sky are the remaining traces of that ancient merger, like lingering memories left behind after a meeting long ago. And the story is far from over. Roughly 2.5 million light-years away, the Andromeda galaxy is quietly moving toward us at a speed of about 110 kilometers per second. That may sound alarming, but there is no need for concern. It will take another 4 to 5 billion years before our two galaxies truly begin to merge. When they do, it will become one of the grandest events in the history of our local region of the universe. The sky of that distant future will look very different. Immense rivers of stars will stretch across the heavens. Clouds of gas will blaze with the birth of countless new stars. Eventually, the Milky Way and Andromeda will become one enormous new galaxy, sometimes informally called Milkomeda. Among all these cosmic movements, the Milky Way's spiral arms remain one of its most beautiful features. They are not rigid arms spinning like the blades of a fan. Instead, they are regions where matter becomes temporarily more concentrated, rather like waves of slow-moving traffic along a busy highway. As clouds of gas and dust pass through these denser regions, they become compressed, triggering the birth of new stars. That is why the spiral arms shine so brilliantly with young blue stars and glowing nebulae. Surrounding our entire galaxy lies an enormous dark matter halo. We cannot see it through any telescope, yet its invisible presence prevents the Milky Way from flying apart as billions of stars orbit its center. In many ways, the unseen portion of our galaxy is what has quietly preserved its shape and stability across billions of years. Far beyond the spiral arms, we encounter the globular clusters. These are densely packed collections containing tens of thousands, sometimes millions, of stars bound tightly together by gravity. Most of the stars within them are extraordinarily ancient, nearly as old as the Milky Way itself. They are like living chronicles, quietly enduring, silently preserving the earliest chapters in our galaxy's history. Some of the oldest stars ever discovered are more than 13 billion years old. They were born while the universe itself was still very young, not long after the earliest generations of stars first appeared. When their light finally reaches modern telescopes, those ancient stars tell us not only their own stories, but also help astronomers reconstruct the opening chapters of cosmic history. It is a beautiful realization. The night sky is not merely a picture, it is a library. Every galaxy, a book, every globular cluster, a chapter, every ancient star, a line written billions of years ago. Carl Gustav Jung once wrote in The Archetypes and the Collective Unconscious, "The collective unconscious is a part of the psyche which can be negatively distinguished from a personal unconscious by the fact that it does not, like the latter, owe its existence to personal experience, and consequently is not a personal acquisition." Jung was writing about the collective unconscious, the shared psychological structures inherited by humanity, not about galaxies or the large-scale architecture of the universe. His work explored how universal patterns of the psyche exist independently of any one person's individual experiences. Viewed symbolically, however, his insight offers a beautiful parallel. A galaxy is not defined merely by its individual stars. It is also shaped by the invisible relationships that bind them together. Likewise, human beings are formed by more than personal experience alone. Each of us carries patterns, symbols, and psychological depths that have accumulated across the long history of our species. Just as ancient stars continue shining after billions of years, archetypal symbols continue illuminating our dreams, our myths, our art, and our enduring search for meaning. Perhaps this is one of the greatest gifts of looking up at the night sky. The more deeply we observe distant galaxies, the more clearly we realize that every magnificent structure is built from countless small and enduring connections. No galaxy grows in complete isolation. No star exists entirely alone, and neither do we. Every encounter, every memory, every experience becomes another star within the unique galaxy of our inner lives. So as the night grows quieter, let your imagination drift gently along the Milky Way's graceful spiral arms, past its ancient globular clusters, and onward toward Andromeda, quietly drawing nearer across the darkness. For within that slow and patient movement, the universe whispers a timeless truth. Every form of growth requires time. Every meeting leaves its mark. And every journey, whether it spans billions of years or a single human lifetime, becomes part of the vast and beautiful story of existence. Part 10. The origin of the elements. If someone were to ask what human beings are made of, we might first think of blood, bones, muscles, or the countless tiny cells continually renewing themselves within our bodies. All of those answers are true, yet astrophysics offers an answer even more extraordinary, one that can leave us quietly speechless beneath a star-filled sky. Every atom within your body carries a history far older than the Earth itself. Before becoming part of a human being, those atoms once existed deep inside ancient stars. They were forged in temperatures of millions of degrees. They endured some of the most violent events the universe has ever known. In other words, we do not merely live beneath the stars. We are truly made from them. In the aftermath of the Big Bang, the universe was remarkably simple. Almost all matter consisted of hydrogen and helium, with only a tiny amount of lithium, the elements essential for life. Carbon, oxygen, iron, calcium did not yet exist. A universe made only of hydrogen could never have produced forests, oceans, or human beings. For life to become possible, the cosmos first needed immense furnaces capable of creating heavier elements. Those furnaces were the stars. Deep inside a star's core, temperatures and pressures become so immense that hydrogen nuclei continually fuse into helium. As the hydrogen supply gradually diminishes, stars with sufficient mass begin fusing helium into carbon. Carbon is a remarkable element. Its extraordinary ability to form stable and complex chemical bonds makes it the foundation of every organic molecule we know. Every cell in your body, every green leaf, every drop of blood, every heartbeat carries the signature of an element forged inside a star billions of years ago. After carbon comes oxygen. We often think of oxygen as a gift from plants because green plants release it through photosynthesis. That is entirely true. Yet plants do not create oxygen from nothing. They simply recycle oxygen atoms that were born long ago inside ancient generations of stars. Every breath we inhale today continues a journey that began while the universe itself was still very young. As massive stars approach the ends of their lives, nuclear fusion continues producing heavier elements: neon, magnesium, silicon, and finally, iron. Iron marks a profound turning point. Unlike the fusion reactions before it, fusing iron no longer releases energy. Instead, it requires energy. When a star's core becomes filled with iron, the delicate balance between outward pressure and gravity collapses. The core implodes, and a brilliant supernova begins. Yet the story of the elements does not end there. The rarest elements, gold, platinum, uranium, require conditions even more extreme. For many years, scientists believed they were created primarily during supernova explosions. Modern observations, however, have revealed another profoundly important source: the kilonova. A kilonova occurs when two neutron stars orbit one another for millions of years before finally colliding. Within only a few brief seconds, they release an almost unimaginable amount of energy. In that extraordinary environment, atomic nuclei capture neutrons with incredible speed through what physicists call the rapid neutron capture process, or R process. There, some of the heaviest elements in the periodic table are born. That means the gold ring resting upon someone's hand, the platinum inside a fine watch, or a uranium atom hidden deep beneath the Earth's surface, may all have originated in the violent union of two neutron stars billions of years before our solar system even existed. It is difficult not to feel moved by that thought. A small piece of jewelry treasured for a lifetime may carry the memory of a collision that happened long before the sun was born. Yet perhaps the greatest wonder of the universe is not simply that it creates the elements. Its greatest wonder lies in the fact that it never wastes them. After every supernova, after every kilonova. Newly forged elements are scattered into space as gas and dust. Over time, gravity gathers those materials together once again. From those clouds, new stars emerge. Around them, new planets slowly take shape. And upon some small world, if conditions are just right, life begins. It is a cosmic cycle of recycling that has continued for billions of years. No atom truly belongs to a single star. No atom belongs forever to a single planet. Each simply continues its journey through one form after another. The carbon atom inside a leaf today may once have existed within a brilliant blue giant star. The iron flowing through your blood may once have formed part of the core of a sun that exploded long before Earth was born. And the calcium in your bones may continue existing long after today's civilization has become only a distant memory. Seen from this perspective, human beings do not stand apart from the universe. We are simply one very small chapter in the long journey of matter itself. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "I am not what happened to me. I am what I choose to become." Jung was writing about personal identity, choice, and psychological growth, not about carbon, gold, or kilonovae. His words remind us that although our past shapes us, it does not completely determine who we become. Viewed symbolically, however, his insight beautifully echoes the journey of the elements. An atom carries no fixed destiny. It is continually transformed, continually woven into new structures, from a star to a planet to a living organism, and eventually back into the cosmos. Perhaps human beings are much the same. Our past becomes part of us, but it is not the whole of us. Just as the universe continually reorganizes its matter into new forms, the human spirit always possesses the capacity to grow, to change, and to discover new meaning. Perhaps this is one of the gentlest lessons astrophysics offers us. When we gaze into the night sky, we are not merely looking toward distant stars. We are looking toward our own beginnings. Every breath, every heartbeat, every step we take carries within it the memory of suns that faded billions of years ago. And perhaps that truth makes life even more precious. For within this vast universe, we are not strangers wandering through an unfamiliar place. We are part of a story that began with the first light after the Big Bang, continued within the hearts of the stars, and is still being written through every quiet moment of our lives today. Part 11. Nebulae and the formation of planetary systems. There are nights when we gaze upon the breathtaking images returned by the James Webb Space Telescope or the Hubble Space Telescope. We see immense clouds where shades of blue, red, violet, and gold blend together like paintings created from the very light of the universe itself. They appear as soft as drifting mist, as peaceful as a dream, so beautiful that it is almost impossible to believe they are the places where suns, planets, and perhaps even life itself first begin. Astronomers call these vast clouds nebulae, and if stars are the chapters of the universe, then nebulae are the blank pages upon which entirely new stories are waiting to be written. Nebulae are nothing like the dense clouds floating through Earth's atmosphere. They are enormous regions of interstellar gas and dust stretching across dozens, sometimes hundreds, of light years. By our everyday standards, they are extraordinarily diffuse. Yet because they are so unimaginably vast, they contain enough material to give birth to thousands of future stars. Within that almost perfect silence, gravity quietly continues its work. Hydrogen atoms, tiny grains of dust, slowly, patiently, they draw one another together. There is no sound, no urgency, only gravity and time, gathering matter grain by grain. Across millions of years, one region gradually becomes denser, hotter, and brighter. This is the birth of a protostar. A protostar is not yet truly a star. It is still growing, still gathering material from the surrounding nebula. The light it emits comes primarily from heat generated as matter falls inward under gravity. Only when its core reaches temperatures of millions of degrees and nuclear fusion finally begins, does the protostar become a genuine star. Yet one fascinating detail often goes unnoticed. Not all of the surrounding matter falls into the newborn star. Because angular momentum must be conserved, much of the remaining gas and dust gradually flattens into a vast rotating disk surrounding the young star. This is known as a protoplanetary disk. Seen from afar, it resembles a delicate disk of glowing light, turning almost imperceptibly through the darkness. Yet within that seemingly peaceful disk, countless trillions of tiny dust particles are continually colliding. At first, they stick together to form slightly larger grains. Then, small rocks. Then, asteroid-sized bodies stretching for kilometers. Over millions of years, gravity gradually draws these objects together until they become planets. No builder assembles these worlds. No guiding hand arranges them. Only the simple laws of nature, repeating themselves with almost unimaginable patience. Our own solar system followed precisely such a journey about 4.6 billion years ago. The Earth did not appear all at once. It slowly grew through countless collisions between rocky bodies within the protoplanetary disk. The Moon is also believed to have formed after a colossal impact between the young Earth and another world, roughly the size of Mars. What first appears to be chaos gradually gives rise to order. What seems random ultimately creates the conditions for life. Today, after discovering thousands of planetary systems beyond our own, astronomers have learned something equally remarkable. Planets do not always remain where they were born. After forming, many continue interacting with the gas in the protoplanetary disk, or with neighboring planets. Over time, these interactions gradually alter their orbits. This process is called planetary migration. It helps explain one of astronomy's most surprising discoveries: the hot Jupiters. These are giant gas planets, similar in mass or even larger than Jupiter. Yet they orbit astonishingly close to their parent stars, sometimes completing an orbit in only a few days. According to modern models, most hot Jupiters probably did not form so close to their stars. Instead, they were born much farther away in colder regions before slowly migrating inward. Even planets, it seems, have journeys of their own. The place where something begins is not always where it will remain. No orbit is necessarily permanent. And the more planetary systems we discover, the more the universe reminds us that human imagination has only begun to glimpse its possibilities. Some worlds may be ocean planets, where vast global oceans or immense layers of ice hundreds of kilometers deep cover nearly the entire surface. If such planets truly exist as current models suggest, they would be utterly unlike Earth. There, the ocean would not simply be part of the planet, it would almost define the entire world. Elsewhere, astronomers have discovered planets orbiting two suns. Upon such worlds, sunrise and sunset unfold beneath the light of twin stars, creating landscapes that once belonged only to science fiction. Today, many of these remarkable planets have been confirmed through observation, reminding us that nature is even more imaginative than we once believed. And then there are the universe's loneliest travelers, the rogue planets, worlds that orbit no star at all, no sunrise, no sunset. They drift freely through interstellar space, perhaps cast out from their original planetary systems long ago by powerful gravitational encounters. Cold, dark, silent, yet still complete worlds, continuing their endless journey among the stars. There is something both lonely and profoundly beautiful about that thought. Even in absolute solitude, a planet continues to exist. Carl Gustav Jung once wrote in The Development of Personality, "The greatest and most important problems of life are all fundamentally insoluble. They can never be solved, but only outgrown. Jung was reflecting on psychological growth, not on nebulae or the formation of planets. His point was that many of life's deepest challenges are not eliminated through simple solutions, but gradually transcended as we mature and develop. Viewed symbolically, however, his words echo the quiet way the universe creates new worlds. No planet comes into existence in a single perfect moment. Each one grows through countless collisions, changing orbits, and transformations unfolding across millions of years. Our inner lives are much the same. We do not mature by erasing every difficulty. We grow by gradually becoming larger than the challenges we face. Just as a protoplanetary disk requires immense patience before it becomes a fully formed planetary system, our own sense of self slowly emerges through experience, choice, and quiet transformation. Perhaps this is the most beautiful gift nebulae offer us. They remind us that every great beginning starts with something very small. A blue world like Earth was once nothing more than drifting grains of dust circling a young star. A beautifully ordered planetary system began with collisions that seemed almost chaotic, and perhaps human beings are no different. Every thought, every experience, every dream, every courageous step forward is like another tiny grain of dust within the nebula of the soul. Given enough time, those small beginnings gather together, forming an inner world that grows richer, deeper, and more meaningful. So, as the night continues wrapping the heavens in quiet peace, allow your imagination to drift among those luminous nebulae, where millions of future suns still wait patiently to be born, for they whisper one gentle truth that belongs equally to the universe and to ourselves. Every beginning requires time, and every living world first begins as a single grain of dust. Dreaming of Light, Part 12, Exoplanets, Worlds Beyond Our Solar System. Perhaps one of humanity's oldest questions is this: are we alone in the universe? Ever since people first looked up at the night sky, that question has quietly accompanied every civilization. The tiny lights scattered across the heavens were once imagined as gods, the spirits of ancestors, or lanterns suspended from the vault of the sky. Today, thanks to powerful modern telescopes, we know that many of those distant points of light possess planetary systems of their own. There are frozen worlds, endless oceans, strange atmospheres, and weather unlike anything we have ever experienced. With every new discovery, the ancient question grows even deeper. If nature can create such an astonishing variety of worlds, how many more still wait quietly to be found? One of the most remarkable facts is that the vast majority of exoplanets are never seen directly. They are simply too far away, and the brilliance of their parent stars overwhelms the faint light they might otherwise reflect. So astronomers have learned to recognize invisible worlds by studying the smallest traces they leave behind. One of the most successful techniques is called the transit method. When a planet happens to pass directly in front of its star from Earth's point of view, it blocks a tiny fraction of the starlight. The decrease may amount to only a few thousandths, or even less. Yet modern telescopes can measure such minute changes with astonishing precision. If the dimming repeats at regular intervals, astronomers know that a planet is orbiting that star. Using this technique, NASA's Kepler mission, and later TESS, discovered thousands of exoplanets, transforming modern astronomy. Another beautifully subtle technique is known as radial velocity. At first glance, it appears that a planet simply circles its star. In reality, both objects orbit a shared center of mass. As a result, the star itself moves ever so slightly, sometimes toward Earth, sometimes away from it. That tiny motion shifts the star's spectral lines through the Doppler effect. Even movements of only a few meters per second are enough for astronomers to calculate the mass of the unseen planet gently tugging at its star. It is extraordinary to realize that humanity can discover a world hundreds of light years away from nothing more than a tiny flicker of light, or an almost imperceptible wobble. Perhaps it reminds us that in science, as in life, the smallest changes sometimes reveal the greatest stories. Today, finding planets is no longer the only goal. Astronomers have begun studying the atmospheres of these distant worlds as well. When starlight passes through a planet's atmosphere during a transit, some wavelengths are absorbed by the molecules within it. The resulting spectrum reveals the presence of water vapor, sodium, carbon dioxide, methane, and many other compounds. Each element leaves behind its own unique fingerprint within the light. By reading those delicate signatures, scientists can determine the composition of an atmosphere on a world no human has ever visited. And once we begin understanding an atmosphere, we also begin understanding the weather of another planet. Some worlds reach daytime temperatures exceeding 2,000 degrees Celsius. Others experience winds racing at thousands of kilometers per hour. Some are tidally locked, forever showing the same face to their parent star. On those planets, one hemisphere remains bathed in perpetual daylight, while the other lies beneath eternal night. There, sunrise and sunset scarcely exist at all. Among the strangest phenomena ever proposed is glass rain. On the planet HD 189733b, temperatures and pressures are believed to allow silicon-containing minerals to condense into tiny particles. Driven by supersonic winds, those particles may fall like rain, not vertically, but almost horizontally. This is no gentle rainfall like the one we know on Earth. It is a world so extreme that nature seems to have written an entirely different set of rules. Not every planet succeeds in holding on to its atmosphere. Worlds orbiting too close to their stars endure intense radiation and powerful stellar winds. Over immense stretches of time, their lighter gases are gradually stripped away into space. A planet that was once rich in atmosphere may slowly become dry, silent, and barren. It is another reminder of the delicate balance required for a world to remain hospitable to life. Between stars and planets lies another fascinating class of celestial objects, the brown dwarfs. They are more massive than giant gas planets, yet not massive enough to sustain hydrogen fusion like true stars. During their youth, they may briefly fuse deuterium or lithium before gradually cooling over billions of years. For that reason, brown dwarfs are sometimes called failed stars, yet they are far more than failed attempts. They are a unique family of objects that helps astronomers better understand the boundary between planets and stars. This naturally leads many people to wonder about Jupiter. The largest planet in our solar system possesses roughly 318 times the mass of Earth and is composed primarily of hydrogen and helium. Yet to ignite sustained hydrogen fusion like our Sun, an object would need approximately 80 times Jupiter's mass. Missing only that one crucial condition, Jupiter remains forever a planet, never a star. Sometimes, nature reminds us that even a small difference in the beginning can lead to an entirely different destiny. Carl Gustav Jung once wrote in Modern Man, "In search of a soul, the least of things with a meaning is worth more in life than the greatest of things without it." Jung was reflecting on meaning in human life, not on exoplanets or distant planetary systems. His work explored how purpose and significance shape our psychological experience far more deeply than size or outward achievement alone. Viewed symbolically, however, his words beautifully illuminate humanity's search among the stars. We do not seek other worlds merely out of curiosity, or to lengthen a catalogue of discoveries. What we are truly searching for is meaning. Every newly discovered exoplanet reminds us that Earth is not the center of the universe. At the same time, each discovery invites us to treasure even more deeply the extraordinary fragility and beauty of the world we already call home. In Jungian psychology, every outward journey is also, in some measure, an inward one. The farther we explore the vastness of space, the more deeply we come to understand our own place within the greater story of existence. And now, as the night settles into even deeper stillness, and the stars continue shimmering overhead, imagine that around countless distant suns, there are worlds no human being has ever touched. Some may know rain made of glass. Some may be covered by endless oceans. Some may never witness a sunrise. And perhaps somewhere, there are skies that look remarkably like our own, though separated from us by hundreds, or even thousands, of light years. They quietly remind us that the universe is always larger than anything we have yet imagined. And perhaps, like the human soul itself, the deeper we explore, the more we discover that the greatest beauty lies not in having every answer, but in remaining humble enough to continue walking, guided by wonder, and by the questions that still await us. Part 13. The Sun and the Solar System. Every morning, when the first rays of sunlight touch the Earth, we welcome them as something so familiar that we scarcely pause to notice them. That light slips gently through our windows. It warms the streets, awakens the trees, and carries with it the quiet rhythm of a new day. Yet few of us stop to consider that behind such gentle light stands an immense star that has shone steadily for more than 4 billion years. To the universe, the Sun is only an average star, but to Earth, it is the source of nearly every form of life, every river, every breeze, every breath we take. Perhaps the more we learn about the Sunday, the more we realize that life has always been sustained by the quietest and most enduring of gifts. The Sun's story began about 4.6 billion years ago within a vast cloud of gas and dust inside the Milky Way. It was a cold nebula composed primarily of hydrogen and helium. Under the patient influence of gravity, that enormous cloud slowly contracted. As more matter gathered toward its center, both pressure and temperature continued to rise. After millions of years, the core of the growing protostar reached nearly 10 million degrees Celsius. At that moment, the first nuclear fusion reactions began. Hydrogen started fusing into helium, releasing an immense amount of energy. A new star was born, our Sunday. Since that day, the Sun has maintained an extraordinarily delicate balance. Gravity constantly attempts to pull its entire mass inward. Meanwhile, the energy generated through nuclear fusion creates an outward pressure that pushes against collapse. For billions of years, these opposing forces have remained in equilibrium. Because of that remarkable balance, the Sun has remained stable, continuing to shine. And because it continues to shine, Earth has maintained temperatures where liquid water can exist, and life has been able to flourish. Yet the Sun gives us far more than light. From its outer atmosphere, streams of electrically charged particles are continuously launched into space at speeds of hundreds of kilometers per second. This flow is known as the solar wind. It spreads throughout the solar system, carrying the Sun's magnetic field and creating an enormous protective bubble called the heliosphere. This vast region surrounds the planets like a great invisible shield, helping separate our solar system from the harsher environment of interstellar space. For Earth, the solar wind is both a challenge and a gift. Without our planet's magnetic field, these charged particles could gradually erode the atmosphere over immense spans of time, much as scientists believe happened to Mars. Fortunately, Earth possesses a powerful magnetic field. As particles from the solar wind encounter the magnetosphere, they are guided along magnetic field lines toward the polar regions. There, they collide with oxygen and nitrogen atoms high in the atmosphere. Those atoms begin to glow, creating graceful curtains of green, red, and violet light across the night sky. This is the aurora. For those fortunate enough to witness it in person, the aurora is far more than a physical phenomenon. It resembles delicate ribbons of light dancing slowly through the darkness. What makes it even more beautiful is knowing that its journey began millions of kilometers away, with tiny particles that once departed from the Sunday. Once again, the universe reminds us that its greatest beauty often emerges from the quiet precision of simple natural laws. Although scientists have studied the Sun for centuries, they still cannot see directly into its interior. Instead, they listen to it. This remarkable field of study is known as helioseismology. Much as geophysicists study Earth's interior by observing seismic waves generated by earthquakes, solar physicists study tiny oscillations on the sun's surface to reveal what lies beneath. Sound waves continually travel through the sun's blazing plasma before reflecting back toward the surface. Those waves carry information about the temperature, density, and movement of the sun's hidden layers. There is something wonderfully poetic about that. Even a star has its own heartbeat, not the beating of a heart, but the rhythm of matter and energy, in perpetual motion. One fact often surprises people. Sunlight does not arrive on Earth instantly. Although light travels at nearly 300,000 kilometers per second, it still requires about 8 minutes and 20 seconds to cross the approximately 150 million kilometers separating the Sun from Earth. That means whenever we look at the Sunday, we are always seeing it as it was more than 8 minutes ago. Yet the journey of those photons is even more extraordinary. A photon, born deep within the Sun's core, cannot simply travel straight outward. The solar core is so incredibly dense that each photon is repeatedly absorbed and re-emitted in countless random directions. It collides endlessly with surrounding particles of hot plasma, wandering like a traveler lost inside an immense labyrinth. According to modern physical models, a single photon may spend hundreds of thousands of years, perhaps even longer, making its slow escape from the Sun's core to its visible surface. And yet, once it finally leaves the surface, it requires only a little more than 8 minutes to reach Earth. It is astonishing to realize that the sunlight warming your hand this morning may have begun its journey long before modern humans ever walked upon our planet. The universe is patient in precisely that way. It never rushes, it never hurries. It allows time to complete its quiet work. Carl Gustav Jung once wrote in The Archetypes and the Collective Unconscious, "The sun is the natural image of God, the source of light, warmth, and life." Jung was not discussing astrophysics or the physical sun itself. He was exploring the sun as a universal psychological symbol that appears throughout mythology, religion, dreams, and the symbolic life of the human psyche. Within Jungian psychology, the sun represents consciousness, the illuminating center that brings awareness to our inner world. Viewed symbolically alongside astronomy, this image becomes especially meaningful. Just as sunlight undertakes an astonishingly long journey before finally reaching Earth, the growth of human consciousness also unfolds gradually. It does not arrive in a single moment. It requires time, experience, patience. Little by little, awareness reaches the hidden places within us, gently illuminating what was once unknown. Perhaps that is the deepest gift the sun offers. It nourishes forests, oceans, and every living creature. But it also quietly reminds us that the most enduring things are always formed slowly. A photon spends hundreds of thousands of years escaping the sun's core. A star requires millions of years to mature. A planet needs billions of years before it becomes capable of supporting life. Perhaps human beings are no different. The finest qualities of the soul rarely appear overnight. They grow gradually through experience, through loss, through hope, and through every courageous step forward. And now, as night gently embraces the sky and the sun slips beyond your horizon, remember that on the other side of our world, it continues shining, just as it has for billions of years, and perhaps, just as its light always finds its way to Earth, the light of understanding will also find its way into every human heart, if we are patient enough to wait for its arrival. Part 14. High-energy phenomena. When we look up at the night sky, we often feel a profound sense of peace. The stars shimmer quietly. The Milky Way stretches gently across the horizon. Yet hidden beneath that tranquil beauty lies a universe alive with energies far beyond human imagination. There are explosions that release more energy than billions of suns combined. There are particles that pass straight through an entire planet, leaving almost no trace behind. There are ripples in space-time itself, silently traveling across the cosmos for billions of years before finally reaching Earth. What is remarkable is that these immense forces do not create chaos. Instead, they unfold according to laws of extraordinary precision and harmony. It is as though even nature's most violent powers belong to a deeper order, one that humanity is only beginning to learn how to hear. Among the most mysterious visitors continually arriving at Earth are the cosmic rays. Despite their name, they are not rays of light. They consist primarily of protons and atomic nuclei traveling at speeds astonishingly close to that of light. They originate from many different sources: supernova explosions, active supermassive black holes, and distant active galaxies. Every day, billions of these particles enter Earth's atmosphere, creating showers of secondary particles as they collide with atmospheric atoms. Fortunately, our atmosphere and magnetic field protect us from almost all of their effects. Yet their constant arrival reminds us that our small planet has never truly been isolated from the rest of the universe. If cosmic rays are already astonishing, then gamma-ray bursts, or GRBs, are even more extraordinary. In only a few brief seconds, a gamma-ray burst can release as much energy as our Sun will produce over billions of years. Today, astronomers believe that most long-duration gamma-ray bursts arise when enormously massive stars collapse to form black holes. Shorter bursts are thought to result primarily from the merger of two neutron stars. These events are among the brightest beacons in the universe, allowing us to glimpse regions of space that are both unimaginably distant and unimaginably ancient. There is another phenomenon that continues to puzzle astronomers: the fast radio bursts, or FRBs. These are incredibly brief pulses of radio waves lasting only a few thousandths of a second, yet carrying enormous amounts of energy. Some appear only once, never to be seen again. Others repeat, following patterns that are still not fully understood. Recent observations suggest that at least some FRBs may originate from magnetars, neutron stars possessing the strongest magnetic fields known in nature. Even so, their complete origin remains an open question, making FRBs one of the most fascinating mysteries in modern astronomy. Among all these energetic particles and forms of radiation travels another extraordinary messenger: the neutrino. Its mass is incredibly small. It carries no electric charge, and it interacts so weakly with matter that it can pass almost effortlessly through entire planets. Every second, tens of trillions of neutrinos produced by the Sun pass through each of our bodies without leaving the slightest sensation. They travel through mountains, through oceans, even through the Earth itself. Because neutrinos are so reluctant to interact with matter, they are extraordinarily difficult to detect. Yet that very quality makes them priceless. They carry almost untouched information from places hidden deep inside exploding stars, and from the Sun's own core, regions where ordinary light cannot tell the whole story. A beautiful example occurred in 1987, when astronomers observed supernova 1987A in the Large Magellanic Cloud. It was the closest supernova to Earth ever studied with modern instruments. What made it truly remarkable was that underground detectors recorded a small burst of neutrinos several hours before the visible light from the explosion arrived. The neutrinos escaped from the collapsing stellar core almost immediately. The light, however, required additional time to fight its way through the star's outer layers. For the very first time, humanity did not merely see a star die. We heard its first whisper. The story did not end there. In 2015, nearly a century after Albert Einstein predicted their existence through general relativity, scientists working with the LIGO observatories made the first direct detection of gravitational waves. These are not waves traveling through air or water. They are ripples in the very fabric of space-time itself. They arise when enormously massive objects, such as black holes or neutron stars, collide and merge. The signal detected by LIGO originated from the merger of two black holes approximately 1.3 billion light-years away. That means the tiny ripple measured here on Earth began its journey, while complex, multicellular life on our planet had not yet fully emerged. Perhaps it remains one of the most beautiful moments in modern science. Humanity no longer observes the universe only through light. We have begun to listen to it. From that breakthrough emerged an entirely new field, known as multi-messenger astronomy. Rather than relying solely upon visible light, astronomers now combine many different cosmic messengers. Light across every wavelength, cosmic rays, neutrinos, and gravitational waves. Each speaks its own language. Light tells the story of a surface. Neutrinos reveal what happens deep within hidden stellar cores. Gravitational waves describe the dance of enormous masses through space-time. Together, they create a far richer picture of the universe's most powerful events. It is much like listening to a symphony. If we hear only the violin, the melody is still beautiful. But only when the entire orchestra begins to play does the music become complete. Carl Gustav Jung once wrote in The Structure and Dynamics of the Psyche. The psyche consists essentially of images. Jung was writing about the symbolic nature of the human psyche, not about gamma rays, neutrinos, or gravitational waves. His work explored how the mind understands reality through many forms of symbolic experience rather than through rational thought alone. Viewed symbolically, however, his insight resonates beautifully with modern astronomy. We no longer rely upon a single kind of observation to understand the universe. Instead, we learn by listening to many different voices. Within Jungian psychology, the journey towards self-understanding follows a similar path. Conscious awareness grows not only through logical thinking, but also through dreams, emotions, intuition, and the symbolic images emerging from the unconscious. Only by listening to all of these inner messengers can we gradually approach a more complete understanding of ourselves. Perhaps that is the gentlest lesson offered by the universe's highest energy phenomena. Behind every brilliant explosion, every silent neutrino, and every nearly invisible ripple in space-time, lies the quiet reminder that reality is always richer than what our eyes alone can perceive. Just as the universe requires many different messengers to tell its full story, the human soul also requires many different ways of listening before it can fully know itself. And now, as night continues spreading peacefully across the sky and the stars shine quietly overhead, let your imagination drift alongside those invisible waves traveling endlessly through space. For perhaps, within the stillness of this very moment, you, too, have become one small note within the vast cosmic symphony that the universe has been patiently performing for nearly 14 billion years. Part 15. The greatest mysteries of the universe. After journeying together through the lives of stars, black holes, galaxies, nebulae, and distant worlds, perhaps it feels as though we now understand the universe a little better than before. Yet something remarkable happens the deeper science explores. The more we discover, the more we realize how much remains unknown. Everything we know is like a small island rising from an endless ocean of mystery. Our most elegant equations, our most powerful telescopes, our most advanced spacecraft, all eventually arrive before questions that no one can yet answer completely. These mysteries are not signs of failure. They are gentle reminders that the universe is still far greater than our imagination. One of the most profound discoveries in modern physics is the existence of the Higgs field. According to the standard model of particle physics, this field permeates the entire universe. It cannot be seen. It cannot be touched. Yet when fundamental particles interact with the Higgs field, they acquire mass. The discovery of the Higgs boson at the Large Hadron Collider in 2012 provided powerful evidence that this remarkable field truly exists. Perhaps the most astonishing realization is this: mass, something we usually think of as an inherent property of matter, may instead arise through interaction with an invisible field present everywhere in space. That discovery quietly reminds us that some of the most important things in existence are invisible. An even deeper mystery concerns antimatter. Every particle of ordinary matter possesses a corresponding antiparticle with the opposite electric charge. When matter and antimatter meet, they annihilate one another completely, transforming their mass into pure energy. According to our best current models, the Big Bang should have created almost equal amounts of matter and antimatter. Had that balance been perfect, they would have destroyed one another almost entirely in the early universe. Little would have remained beyond light itself. But that is not what happened. For reasons science still does not fully understand, matter exceeded antimatter by only a tiny amount, roughly one extra particle for every billion pairs. That unimaginably small imbalance became everything we now see: galaxies, stars, Earth, and ourselves. In a very real sense, all life in the universe owes its existence to a tiny asymmetry whose ultimate cause remains unknown. Whenever we look into the night sky, we are also looking into the universe's distant past. Astronomers believe that after the cosmic dark ages, the first stars finally ignited. These are known as population 3 stars, the very first generation of stars in cosmic history. Unlike stars today, they were composed almost entirely of hydrogen and helium. The heavier elements, carbon, oxygen, iron, did not yet exist. Current models suggest that these first stars were enormously massive, extremely hot, and astonishingly short-lived. They ended their lives in spectacular explosions, forging the first heavy elements and preparing the universe for every later generation of stars. To this day, however, no population 3 star has ever been observed directly. They remain the universe's earliest witnesses, patiently sought through observatories such as the James Webb Space Telescope. There is something deeply moving about that thought. Every story has its first chapter, and yet the first chapter of the universe itself is still being reconstructed, one ancient photon at a time. Then another question quietly appears. What lies beyond the cosmic horizon? Because light travels at a finite speed, and because the universe is approximately 13.8 billion years old, we can observe only a limited region of the cosmos. This is known as the observable universe. The cosmic horizon is not a wall, nor is it the edge of space. It is simply the greatest distance from which light has had enough time to reach us since the Big Bang. So, what exists beyond it? Today, science does not know. Perhaps space simply continues onward, filled with more galaxies much like our own. Perhaps matter is arranged in ways similar to everything we already observe. Or perhaps entirely unfamiliar structures exist beyond anything we have yet imagined. The important point is that every serious scientific proposal begins with the same humility. At present, there is no direct observational evidence that allows us to know. That uncertainty leads naturally to one of the greatest questions ever asked. Is the universe infinite? Current measurements indicate that, on the largest scales, space appears remarkably close to being geometrically flat. A flat universe could indeed be infinite, but it could also be finite, while possessing a geometry so subtle that we have not yet learned to recognize it. For that reason, modern cosmology cannot yet state with certainty whether the universe is finite or infinite. It remains one of the great open questions of science. Perhaps what matters most is not that we still lack the answer. Perhaps what matters most is that we continue asking. Those questions carried humanity from nights spent observing the stars with the naked eye, to telescopes capable of seeing almost back to the dawn of the universe itself. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "The least of things with a meaning is worth more in life than the greatest of things without it." Jung was not writing about cosmology or the mysteries of the universe. He was reflecting on the importance of meaning in the human psyche, suggesting that our lives are shaped less by possessing every answer, than by discovering significance within our experiences. Viewed symbolically, however, his words beautifully echo humanity's search to understand the cosmos. The universe's mysteries are not empty gaps that diminish knowledge. They are the very reason knowledge continues to grow. Within analytical psychology, Jung often emphasized that the unconscious can never become completely known. There will always remain hidden depths, not to frighten us, but to invite continued exploration, growth, and transformation. In that sense, the outer universe and the inner world seem to share the same quiet truth. The closer we move toward the horizon of understanding, the more new horizons appear before us. And now, as the night grows quieter and the heavens continue stretching endlessly overhead, allow your mind to rest with one gentle thought. Perhaps the greatest beauty of the universe is not that every mystery has already been solved, but that so many still remain, just as every star illuminates only a tiny portion of the night. Our knowledge also lights only a small part of reality, and perhaps it is precisely because those vast regions of darkness still exist that discovery continues, wonder endures, and each of us may keep walking quietly beneath the stars, with an open heart, welcoming all that is still unknown. Part 16. The tools that explore the universe. Whenever we look up at a sky filled with stars, we share a longing that is both wonderfully simple and profoundly ambitious, to see just a little farther, to understand just a little more about the immense universe embracing our small planet. Our eyes can perceive only a tiny fraction of the sky. The light visible to human vision occupies only a narrow band of the entire electromagnetic spectrum. That means if we rely solely upon our natural sight, we miss most of the stories the universe is quietly telling. For centuries, humanity has continued inventing new instruments, not to replace our eyes, but to extend them. Every telescope, every detector, every method of observation, each has become another sense, allowing us to hear a different language spoken by the cosmos. One of the greatest symbols of modern astronomy is the James Webb Space Telescope. Positioned near the L2 Lagrange point, approximately 1.5 million kilometers from Earth, James Webb observes the universe, primarily in infrared light, rather than visible light. That gives it an extraordinary advantage. The light from extremely distant galaxies has been stretched by the expansion of the universe, shifting from visible wavelengths into the infrared. Because of this, James Webb can observe galaxies that formed only a few 100 million years after the Big Bang, bringing us closer than ever to the dawn of the universe. Infrared light offers another remarkable gift. Clouds of interstellar dust often block visible light, but infrared wavelengths can pass through much of that dust. As a result, James Webb can peer inside nebulae, watch stars being born, and observe protoplanetary disks quietly assembling entirely new worlds. Places that once appeared as darkness have become landscapes rich with detail and possibility. Yet light is not the universe's only language. At much longer wavelengths, radio astronomy opens an entirely different window onto the cosmos. Enormous radio telescopes do not collect visible light as our eyes do. Instead, they detect radio waves emitted by hydrogen gas, pulsars, quasars, and countless other celestial objects. Through these observations, astronomers map the structure of the Milky Way, study cosmic magnetic fields, and investigate regions completely hidden from optical telescopes by thick clouds of dust. Meanwhile, infrared astronomy allows us to observe relatively cool objects, nebulae, brown dwarfs, and dusty disks surrounding young stars. It is within the infrared that the cradles of newborn stars reveal themselves most clearly. Places that appear calm and quiet are, in fact, patiently preparing the next generation of suns. At the opposite end of the electromagnetic spectrum lies X-ray astronomy. X-rays are produced only in environments of extraordinary heat and energy, gas spiraling around black holes, neutron stars, supernova remnants, and enormous clusters of galaxies. If infrared astronomy tells the story of birth, then X-rays tell the story of the universe's most violent transformations. Using specialized space observatories, scientists can explore places where matter is heated to millions of degrees, and gravity approaches its greatest extremes. Yet perhaps one of astronomy's most powerful tools is not a telescope at all. It is a technique called spectroscopy. When light from a star passes through a prism or a diffraction grating, it separates into a spectrum of colors. Within that spectrum appear distinctive bright and dark lines. Every chemical element leaves behind its own unique fingerprint. Simply by studying those delicate patterns, astronomers can determine what a star is made of, how hot it is, how rapidly it rotates, and even whether it is moving toward us or away from us. There is something almost magical in realizing that we can understand the nature of an object millions of light years away, simply by carefully examining its light. In humanity's effort to measure the immense distances of the universe, one discovery proved especially foundational: the Cepheid variable stars. These remarkable stars brighten and fade with astonishing regularity. Early in the 20th century, astronomer Henrietta Swan Leavitt discovered that a Cepheid's pulsation period is directly related to its true luminosity. That relationship became one of astronomy's most reliable standard candles, allowing scientists to measure distances to faraway galaxies. Building upon her quiet yet revolutionary work, Edwin Hubble later demonstrated that the Milky Way is not the universe's only galaxy, and that the universe itself is expanding, a discovery that seemed small at first, ultimately transformed humanity's understanding of the cosmos. Several decades later, another astronomer quietly changed our understanding of galaxies: Vera Rubin. While studying the rotation of stars in the outer regions of galaxies, she found that they were moving far faster than visible matter alone could explain. Her work became one of the strongest pieces of evidence for the existence of dark matter, the invisible substance believed to account for most of a galaxy's mass. Sometimes, what we cannot see determines the shape of everything we can. Then, in 2019, humanity reached another historic milestone. The Event Horizon Telescope released the first image of the shadow of a supermassive black hole. Remarkably, this was not the achievement of a single telescope. It was created by a worldwide network of radio observatories working together through very long baseline interferometry, or VLBI. For a brief moment, our entire planet became one giant telescope. That image represented more than a technological triumph. It became a testament to the power of human collaboration, patience, and scientific curiosity. Looking back across this remarkable journey, we discover that every tool built to explore the universe shares the same purpose: not to change the universe, but to expand the limits of human perception. These instruments do not create new realities. They simply reveal what has always been there, waiting to be seen. Carl Gustav Jung once wrote in The Undiscovered Self, "The world hangs on a thin thread, and that is the psyche of man." Jung was not writing about the James Webb Space Telescope or radio observatories. He was reflecting on the human psyche and its central role in shaping how we experience and understand the world around us. Viewed symbolically, however, his words beautifully complement the story of scientific discovery. Every telescope extends our vision outward. At the same time, it quietly reflects the remarkable capacities of the human mind itself. Within Jungian psychology, the inward journey resembles the construction of an ever more refined telescope. Little by little, we learn to see beyond our assumptions, to listen for the faintest signals arising from the unconscious, and to recognize that beyond everything illuminated by consciousness lies an even deeper inner world. Perhaps that is the greatest beauty of science. Every telescope carries us closer to distant galaxies, yet each one also teaches us humility. The farther we see, the more we realize how much remains unseen. just as the night sky has always contained far more than our eyes alone can perceive. The human soul has always been larger than anything we can understand in a single moment. And now, as darkness settles gently across the heavens and the stars continue shining above, let your imagination travel alongside the gaze of the James Webb Space Telescope. Listen to ancient radio waves crossing the cosmos. Read the delicate fingerprints hidden within starlight, and join generations of patient scientists as they uncover one mystery after another. For perhaps every step we take toward understanding the sky is also a step toward understanding ourselves. Part 17. The universe is a story that never ends. Perhaps, when we first began this journey, we simply wanted to know what the night sky was made of. We were curious about the stars shimmering overhead, the distant galaxies, and the mysterious black holes from which not even light can escape. But the farther we traveled, the more patiently we listened, the more we discovered that the universe is far more than a collection of planets, stars, or physical equations. The universe is a story told through light, through time, and through a patience that seems almost without end. It is a story that began about 13.8 billion years ago, and even today, it is still being written. Throughout that journey, we have learned something quietly beautiful. Every great discovery begins with something very small. A star that dims by only the slightest amount reveals a planet hundreds of light years from Earth. A tiny shift within a spectrum uncovers the presence of an invisible world. A handful of neutrinos arriving before the light tells us the final moments of a massive star. A delicate ripple in space-time confirms that two black holes merged more than 1 billion years ago. A faint ring of light surrounding a dark shadow becomes humanity's first image of a black hole, something generations of scientists once believed might never be seen. None of these discoveries began with something loud. They began with patience, with the willingness to notice what is almost imperceptible, with the quiet confidence that nature always leaves traces for those who are willing to look carefully enough. Perhaps that is what makes science so beautiful. Science does not diminish the wonder of the world. It makes wonder something we can explore. When we understand why the aurora dances across the sky, we do not admire it any less. When we learn how a star is born, the heavens do not become ordinary. When we discover that black holes curve space-time, or that sunlight needs more than 8 minutes to reach Earth, the universe loses none of its beauty. Instead, every answer opens the door to still more questions. And with each new question, our sense of wonder grows even deeper. That is one of science's greatest gifts. It does not replace imagination. It gives imagination a firm foundation from which to soar. And after all the galaxies, the nebulae, and the ancient stars, perhaps the discovery that moves us most is also the simplest. Human beings are made of stardust. The carbon atoms within every cell were forged inside stars that have long since faded away. The oxygen we breathe was created through nuclear fusion billions of years ago. The iron flowing through our blood, the calcium within our bones, the gold in a wedding ring, and the uranium hidden deep beneath the Earth, all owe their existence to exploding stars and ancient collisions between neutron stars. Perhaps that means the distance between ourselves and the universe has never been as great as we once imagined. We do not stand outside the universe, observing it from afar. We belong to its story. Every breath carries the history of stars. Every heartbeat is built from atoms that have traveled across the cosmos for billions of years. And when we lift our eyes toward the heavens, we are no longer looking at something separate from ourselves. We are looking toward our own beginnings. Yet perhaps what makes this story most extraordinary is that it is still unfolding. The universe has never stood still. Space continues to expand. Galaxies continue drifting farther apart. New stars continue emerging from cold nebulae. Aging suns continue moving quietly toward the ends of their lives. New planets continue forming around young stars. Black hole mergers continue sending gravitational waves across the cosmos. Ancient photons continue journeys lasting billions of years before one day reaching a human telescope. Everything continues to change. Everything continues to evolve. Everything continues telling a story that has never truly ended. Perhaps the same is true of our own lives. None of us is a finished manuscript. None of us remains completely unchanged. With every passing day, we continue learning, changing, and growing. Sometimes so slowly that we hardly notice it ourselves. Just as a galaxy requires billions of years to take shape, the human soul also needs time to discover its own balance, its own peace, and its own meaning. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "In all chaos there is a cosmos. In all disorder, a secret order." Jung was not writing about the expansion of the universe or the evolution of galaxies. He was reflecting on the psychological life of human beings, suggesting that beneath confusion and inner conflict, there often exists a deeper pattern waiting to be recognized. Viewed symbolically alongside the universe, however, his words offer a gentle conclusion to everything we have explored together. What first appears chaotic in the cosmos is often governed by profound natural laws. Perhaps our inner lives are much the same. Our uncertainties, our losses, our quiet moments, our unexpected changes may all belong to a larger pattern that we cannot yet fully see. Within Jungian psychology, maturity does not come from eliminating darkness. It comes from gradually discovering the meaning quietly hidden within it. And now, our journey through the universe gently comes to its resting place. Allow every image we have shared to settle peacefully within your mind. Imagine the night sky stretching endlessly above you, where hundreds of billions of galaxies continue their silent dance, where new stars are quietly being born inside glowing nebulae, where ancient light still travels patiently across the darkness, carrying stories from the distant past. There is no need to remember every number or every scientific term. Simply carry with you the quiet feeling that you belong to a universe that is vast, beautiful, and deeply meaningful. And now, as your eyes grow heavier, allow your breathing to become slower, deeper, more peaceful. Let the stars continue shining in place of every unfinished thought. Let the Milky Way gently cradle your sleep, just as it has watched over countless generations throughout human history. And perhaps, within a dream filled with quiet wonder, your journey among the galaxies will continue, not in search of the universe's ending, but in the realization that its greatest beauty has always been this. It never stops telling its story. Perhaps, when this journey first began, we simply wanted to explore the night sky. We were curious about the shimmering stars, the distant galaxies, the mysterious black holes, and the questions humanity is still striving to answer. But now, after traveling together across billions of years of cosmic history, from the first light after the Big Bang to the modern telescopes reaching toward the farthest edges of observable space, we may have discovered that this journey was never only about the stars. It has also been a journey toward understanding ourselves. Every chapter in the universe's story reflects something deeply familiar within our own lives. Stars are born from clouds of dust that once seemed shapeless. Galaxies grow through countless encounters and mergers. The elements that make life possible are forged within the blazing hearts of ancient suns. Then, after billions of years of transformation, those very atoms become part of the oceans, the forests, every living creature, and each one of us. That means every time you take a slow, gentle breath, every time your heart beats quietly within your chest, you carry a history older than any civilization that has ever existed on Earth. The atoms within your body once traveled through exploding supernovae. They drifted among glowing nebulae. They helped shape other worlds long before they became part of the person you are today. There is something deeply peaceful in that realization. It reminds us that we have never truly been separate from the universe. We belong to it, and in a beautiful way, the universe also lives within us. Science does not take away the world's magic. Instead, it allows us to see that behind every wonder lies a pattern of extraordinary elegance. Knowing why the aurora dances across the sky does not make it any less beautiful. Understanding how stars forge carbon and oxygen does not make life feel any less miraculous. Realizing that sunlight may spend hundreds of thousands of years making its way from the sun's core before needing only 8 more minutes to reach Earth simply makes every sunrise feel even more precious. Perhaps knowledge does not diminish mystery. Perhaps it teaches us to experience wonder more deeply. Carl Gustav Jung devoted his life to exploring another kind of universe, the universe of the human psyche. Astronomers, meanwhile, have devoted theirs to exploring the heavens above. These two journeys may seem very different, yet both begin in exactly the same place, with the courage to step into what we do not yet know. Perhaps that is the most beautiful message this journey has hoped to share with you. Do not fear questions that have no answers yet. Do not rush through what cannot be fully understood today. Even the universe has never stopped changing. Galaxies continue drifting farther apart. New stars continue to be born. New planets continue taking shape. Ancient light continues crossing the vastness of space, patiently traveling until one day it reaches a telescope here on Earth. Everything continues. And so do we. Some days, life feels wonderfully clear. Other days, it resembles a sky hidden behind clouds. But just as astronomers patiently wait for the faintest signal emerging from the immense silence of space, we, too, can learn to be patient with ourselves. Not every answer arrives immediately. Not every journey is meant to be completed quickly. Sometimes the most important thing is simply to keep moving forward, to keep learning, and to keep carrying within our hearts a quiet curiosity about the world around us. And now, as the night grows even quieter, allow your thoughts to slow. Imagine hundreds of billions of galaxies turning silently above you. Somewhere, a new star is being born within a glowing nebula. Somewhere, a young planet is completing its very first orbit around its star. Somewhere, an ancient photon continues a journey that has lasted billions of years. And here, on this small blue world, you too are part of that vast story. Allow your breathing to become softer. Let your shoulders relax. Let the worries of today dissolve gently. Like morning mist beneath the first light of dawn, the night sky will continue watching over your sleep, just as it has quietly watched over countless generations throughout human history. If tonight you feel even a little more peaceful, if these stories of the universe have helped your mind slow down and your heart open just a little wider, then that is the greatest gift this channel could ever hope to offer. If you enjoy these gentle journeys through science, history, and the deeper landscape of the human mind explored through the perspective of Carl Gustav Jung, we'd love to have you with us. Please consider subscribing, leaving a like, and turning on notifications so you won't miss future stories. Each week, we'll set out on another quiet voyage, where knowledge meets reflection, where science and the human spirit come together, and where every story unfolds at a gentle pace, helping you relax and peacefully close the day. But for now, let the night embrace you with its quiet stillness. May you sleep deeply. May you rest peacefully. And when morning comes, may you carry with you the calm of the night sky, the patience of the stars, and the quiet hope that, just as the universe continues expanding, your own life will always hold new horizons waiting to be discovered. Sleep well, and until we meet again, beneath a sky full of stars,